Hi, I'm John McGuigan. I'm a biologist here at Soft Genetics, and today I'm going to cover how to use the Batch CNV tool in NextGENE software. This tool allows you to load a batch of targeted sequencing projects in order to detect potential copy number variants within the samples based on the coverage. Calls can be automatically made based on simple cutoffs for exon size variants, but it's also possible to look at the normalized coverage at any position and any of the samples to possibly find variants that are smaller than an entire exon. This is performed by using a very simple normalization method, and the result of this normalization is that we have samples with no CNV changes having a coverage of approximately 1. Heterozygous deletion would result in a normalized coverage of about 0.5, and a 1-copy duplication would result in a normalized coverage value of about 1.5. And of course, higher or lower values may indicate a homozygous deletion or multiple copy duplications. The most important thing to remember about this method is that it requires very consistent performance from sample to sample. It's possible that many or even most library preparation methods won't work well with this method, but CCAP Easy Choice from Roche and Imogen is one that has been shown to work very well. To run the tool, it's as simple as loading your batch of projects, loading a bed file that defines the targeted regions, and optionally loading a text file listing names of amplicon regions. This is an option because you have to load the bed file defining all of the targeted regions in the panel, even if you don't want to look at results for all of them. So the text file will allow you to filter down the results to only report what you need after analyzing based on the entire bed file. After clicking OK and running the tool, the results table will open up after a few seconds, and this will list each different region from the bed file in a new row, and there's a column for each loaded project with the average normalized coverage value for that region in that sample. You can click on the graphical results button to open up some more graphical interactive views of the results. The way calls are made is we have just simple cutoffs. So by default, when the average normalized coverage in a region in the sample is above or equal to 1.2, it'll be called as a duplication. And when it's less than or equal to 0.8, it'll be called as a deletion. And these values are, of course, adjustable. Setting them to more extreme values will make the tool a little bit more specific and less sensitive. And setting it to less extreme values, closer to 1, will make it more sensitive but less specific. So this is the first visualization result that we have. In each row, we have a different sample, and in each column, we have a different region. And the squares in the grid are colored according to the call. So blue squares are above that upper limit and are possible duplications, while red squares are below that limit and are possible deletions. You can click on an area in that first grid to update the location of the second visual, and this shows the same results except it shows it for one sample at a time. And you can see the actual values within each region instead of just a simple color. The third and final visualization option will let you look at the value of the normalized coverage within a region. So if you click on a certain region in the first or second visual, this graph will update and show you the values across all the positions in that region. So in this case, you can see the light blue line is the normalized coverage value, and it's above the upper cutoff, which is at 1.2 in blue. On average in this region, the normalized coverage was above that cutoff, so this was called as a duplication region. And now it's time for a quick live demonstration. After running your projects, what you'll want to do is open up the NextGENE viewer. In the comparisons menu, you'll find the Batch CNV tool. And here you can add one project at a time, or much faster is to use the Batch Add option. So with this option, you can navigate to where your alignments are. And here you can see that I have many different alignment projects in this one folder. So I can just click this root folder and load all of my projects automatically. You'll then want to load your bed file that indicates your targeted regions. And you can optionally load a text file which limits the results further from this bed file. You click OK and wait a few seconds. And then the results pop up in their own table. You can save these results to a tab-delimited text file, which makes it easy to load it into other programs. You can click the graphical results button to open up the Batch CNV viewer. And as I covered, this will show you 3 different graphical views of the results. If you double click on a position in the top graph, that sample will show results in the second graph, and that specific sample in that region will show results in the bottom graph. And if we scroll over here, we can see we had one region that was on chromosome X, so we have a sort of measurement identifying samples by gender. And we also have some validated copy number changes in this PMP22 gene in a few of the samples. And you can see, based on the coloring, which regions were above or below our cutoffs on average. And that's really all there is to it. We'd like to thank Dr. Beckham Sadakovic and his colleagues at the London Health Science Center for all of their suggestions, ideas, and feedback during development of this tool, and also for allowing us to use some data to demonstrate the tool. You can find a paper on using this method published in the Journal of Molecular Diagnostics. If you'd like to learn more about using NextGENE, you can visit us on the web at softgenetics.com. We have many webinars available for viewing through the Analysis Corner, and you can find specifics about many different topics in our application notes. For more information, you can contact info@softgenetics.com. Thanks.